In this video we're going to look at how to find exact values for trigonometric ratios given some information about a different trig ratio. So in example 1 here we're asked to find the value of sine theta given that cosine theta is 4/7 and that theta is an acute angle. So first of all, what I'm going to do is I'm going to draw a right angled triangle. And I'm going to let this angle be equal to theta. So if cosine theta is 4/7, then I know if I've got a right angled triangle that cosine theta is equal to adjacent over hypotenuse. So if I mark on 4 as adjacent and 7 as a hypotenuse, I can use Pythagoras' theorem to find the missing side. So 7 squared is equal to x squared plus 4 squared. So 49 equals x squared plus 16. 33 is equal to x squared, and therefore x is root 33. So I've got now a value for each of the sides of my triangle. So now we can deal with the other part of the information. So it says find sine theta given cosine theta is 4/7. So sine theta is opposite over hypotenuse, so root 33/7. So where does this information come in that theta is acute? Now if we consider our angle diagram, then we should know that these letters here represent which quadrants we have positive values. So if theta is acute, it's between 0 and 90, so it's in this quadrant. In that quadrant, all of the ratios are positive, so if cosine theta is positive, sine theta is also positive. So let's look at another example. So this time we're asked to find tan theta given that sine theta is negative a fifth and that pi is less than theta is less than 3 pi over 2. So this tells me that theta is, because it's greater than pi, it's actually a reflex angle. But I'm still going to draw a right angled triangle. And we're always going to do a right angled triangle, and it's always possible to rewrite the trigonometric ratio of an angle as one of an acute angle, which is covered in a previous video. So if that's theta, I'm going to ignore the actual sign here because it's the magnitudes that I'm interested in rather than the sign. So here I've got opposite over hypotenuse, so opposite over hypotenuse. And so now I can use Pythagoras' theorem to find the last one. So 5 squared is equal to x squared plus 1 squared. 25 is equal to x squared plus 1. 24 is equal to x squared. X is equal to root 24. And I might want to write that as root 4 root 6, so 2 root 6. Just because it's a third, I can simplify it. So this length here is 2 root 6. So we want to find tan theta, so tan of theta is equal to opposite over adjacent, so it's equal to 1 over 2 root 6, and then I'm going to rationalise that denominator, so I'm going to multiply top and bottom by root 6, so I get root 6 over 2 times 6, so I get root 6 over 12. But I still need to consider the sign, so I'm going to revert back to an angle diagram here. And it's between pi and 3 pi by 2, so pi is over here and 3 pi by 2 is here, so it's in this quadrant. Now in this quadrant tan is positive, so when sine was negative, in this case tan is positive, so I have root 6 over 12 as my solution.